Hi, today we're going to look at the piezo speaker. And piezo means squeeze or press. The piezo material, they grow and contract when you have a voltage applied. When you apply, high voltage, you might contract. When you have low voltage, it might grow. Also, instead of voltage, you can use for force. But here, we are going to use high and low signal in voltage to control our material, piezo material, then therefore creating sounds, right? When you're vibrating, and it's gonna create the sound. So now let's take a look. If you create this cycle and we create this square wave, and this is gonna be high signal and this is gonna be no signal, and that would be one cycle, and the frequency is how many cycles per second. Period is for each cycle is going to take how long in seconds. For example, if for example you desire to create a frequency of 4,000 hertz of sound, so that means piezo speaker is going to vibrate at 4,000 cycles per second, and 4,000 hertz change to period. It's going to be 1 over frequency because period is reciprocal of frequency. In that words, you get this very small number, 0.00021 second per cycle. And the cycle has both high signal and the low signal, so you're going to divide by 2. That tells us for this half period, that's how long you're going to hold on this high signal, right? And for this particular case, you're going to hold for 125 microseconds. That means 125 microseconds on high voltage and then 125 seconds low. So we're going to use delay function, right? So we're going to using our Arduino and ThinkerCAD to simulate this piezo speaker. So now let's go over there. Okay, so to connecting, this is very simple. You have your piezo speaker, and there's positive end. Ooh, I just realized that. So I need to make a mistake. I made a mistake here. Let's see if that change it. Okay, so still this is positive, and I'm gonna move this a little bit here. So positive, we're going to connect into digital 13, and the negative, we're going to connect into the ground. All right, okay. So very simple wire connection. Now let's look at our code. Our code, we understand the concept of it. We just need to create that square wave, right? So we put the 13 as output, and inside the loop, we're going to keep on transmitting the square wave. In order to do so, we put digital write 13 on high, and a delay here 1. That means for 1,000 milliseconds, right? Actually, I take it back. Delay 1 here, that's comment is not right. Delay 1 means 1 millisecond, right? 1 millisecond is 1,000 microsecond. So we're going to do that. Let's see how that sounds. Let's start simulation. All right, so earlier we had the delay as 1, that means 1 millisecond, that's 1,000 microsecond, right? In that situation, I think the frequency is actually about 1,000 hertz, calculate. And remember in the video, in here, we said if we want to create 4,000 hertz of the sound, this half period is gonna be around 125 microsecond. So that's basically 0.125. Let's try if that make a difference. 0.125. That create frequency of 4,000. Let's see. All right, so you clearly hear different type of frequency of the sound. All right, so that's our piezo speaker for that. And I'll see you next time. Bye.